or substitution. So I'm going to use elimination here because my variables are the same. So I'm going to times this one by 4. And put them together, and I get 13x squared equals 52. So then I divide 52 by 13, and I get x squared equals 4. This is where you got to be very, very careful because it's not x equals 2. It's plus or minus 2. Okay, so now that means I have two answers. X is 2 and x is negative 2. So I need to put 2 and negative 2 into one of these and see what I get. So if I put 2 in for x, I get 4y squared, and then I minus 4 here. So 4y squared equals 4. Y squared equals 1. So again, I get y equals plus or minus 1. So with the positive 2, I get 1 and negative 1. But then also, if I put the negative 2 in here, aren't I going to get the same answer? So I get 1 and negative 1. So I actually have 4 answers. You got to be careful that you're matching up the answers with the ones that work. How can I have so many answers for this? Well, this one here is called an ellipse. And this one here is called a hyperbola. And so that's how I can have 4 answers. Okay, now for this one, I could use elimination or substitution. I'm going to do it with substitution so you can see another way to do it. So I'm going to solve this one here for y. So I get negative y equals negative 2x minus 1. So y equals 2x plus 1. And then I'm going to put that in here. So I get x squared minus y, which is 2x plus 1, equals 2. So I get x squared minus 2x minus 1 equals 2. It's a quadratic, so I need to set it equal to 0. So I'm going to minus the 2. And now I just need to factor it. I need factors of 3 that give me a difference of 2, which is negative 3 and 1. So x equals 3 or negative 1. Remember, I need to write it as 2 different answers. So I already solved for y here. So if x is 3, then y is 6 plus 1, or 7. If x is negative 1, it's negative 2 plus 1. And so don't forget to write all of the answers. You're not just going to have one answer on most of these. Okay? Okay, now this is a part where they could have one solution, no solution, or infinite solutions. Now, they're not going to tell you this on the test. So you won't know if it's infinite or until you solve it. But so we're going to take this equation. Remember, I told you to take these and simplify them if you can, because they try and disguise them. If you can divide everything by 2, do it. Make your numbers smaller. And then divide all of these by 3. And I get negative 3x plus 3y equals negative 5. Now watch what happens when I add these. See, you can't see it from here, but from here, watch, I get 0 equals 0, which means what? It's a true statement, so it's not a false statement, so don't say no solution, it's infinite solutions. Now I have to write the general form of the solution. So I take one of the equations that I got my infinite from and solve it for one of the variables. Well, I'm going to take this one because x is positive, and I'm going to solve it for x. So x equals 3y plus 5. So then I write my xy solution. What does x equal? 3y plus 5. And then y is just y. The infinite part comes by picking something for y and then finding out what value of x goes with that. So that would be the answer for that one. Okay, now we're going to do it with a 3 by 3. So I first need to eliminate one variable twice. Well, I chose to get rid of the x's. So I took this one and times it by -1 and made it -x minus y plus z equals 0. And then x plus 2y, I just rewriting this one, minus 3z equals -3. And I put those two together, and I got y minus z equals, or minus 2z, sorry, equals 3. Oh, this is a -3, isn't it? See, you got to be careful. Don't make mistakes like I'm doing. Okay, now I need to get rid of the x in another one. So I'm going to put these two together, and I'm going to take this one and times it by -2, and let's go up here. So now I'm going to times it by -2. -2x minus 2y plus 2z equals 0, and put it with this one. 2x plus 3y minus 4z equals -3. And when I put those two together, I get y minus 2z. Oh my goodness, sorry. Oh, I lost it. Okay. So let's put these two back together again, sorry. So -2x plus -4y, because I'm timesing this one by -2. Plus 6z equals 6, and put it with this one. Minus 4z equals -3. And I get -y plus 2z equals 3. And remember, the other one that I had was y, so I got -y plus 2z equals 3. And the other one that I had was y minus 2z equals -3. So again, I get 0 equals 0. So now, again, I need an x, y, z. So I choose one of the equations. I'm going to choose this one because y is by itself and it's not negative. And I get y equals 2z minus 3. So that's what y equals, 2z minus 3. Well, to find y, I have to have chose something for z. So one of the variables is locked in just as x, y, or z. But the other two have to be in terms of z. So now, if I had y and z here, I could solve for x, couldn't I? Well, I actually do have y and z. They're just in terms of z. So I'm going to take this and put these two in. So I'm going to take x plus, what do I have for y? 2z minus 3 minus z, which is just z, equals 0. So I get x plus 2z minus 3 minus z. I'm going to put these two together and get x plus z minus 3. Well, remember, we're trying to solve for x, so I get x equals -z plus 3, and put that in here. And you can check this to make sure it's right by picking a value for z. Let's pick 1 for z. So then 2 minus 3 would be -1, and then this would be 2. So this should be a solution that works. Let's try it in this one. 2 times 2 is 4, plus 3 times -1, minus 4. Does that equal -3? Yes, it does. So it doesn't mean this is my only solution. It means it's one solution, but it's a good way to check and see if you got the answers right. So that's it for that.